Dr. Kole, have you joined?
The person you are calling is not answering. Please call again later.
Dr. Kole, can you hear me? So hope Dr. Kole has joined. Yeah. So Rohit, please unmute Dr. Tanmoy Kole. Rohit, can you hear me?
Done, sir, done.
Yeah. So Dr. Kole,
Shall
are you there? Yeah.
shall I share this?
No. Just wait a minute. Just wait a minute. Okay. So 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 in the during this post-lunch session, we had two lectures particularly. So I, on behalf of our Crop and Weed Science Society, once again I welcome you all the delegates to be present here. So the next session will be the session coordinator will be Dr. Nilesh Bhoumik, Professor, Department of Pomology and Fruit Post Harvest, who will gonna coordinate this session. So I am requesting Dr. Bhoumik to please coordinate this session within the stipulated time as we are running late. So please request the respective speakers to be in time so that we can accommodate all the lectures within our stipulated time frame. So thank you. It is now handed over to Dr. Bhoumik, please. Dr. Bhoumik, are you here?
Yes.
Yeah.
Okay. Good afternoon to everybody.
and I welcome Dr. Tanmoy Kumar Kole for this particular session, and he will be delivering one lecture on microgreens and high-tech horticulture for income generation. Dr. Kole, actually, he is presently working as senior scientist at ICAR Research Complex for Eastern region, that is in Patna. Presently, he is working on plant phenolics, plant pigments, microgreens, as well as their nutraceutical properties on different minor food crops as well as vegetable crops. So with this, I would like to introduce Dr. Tanmoy for his lecture, and I should also request him, please restrict your lecture within 20 to 25 minutes, and after that 10 minutes discussion along with the participants. So participants are also requested that is just go through the lecture very carefully, and if you have in your mind anything, you can actually put your message on chat box also, so that we can record it, and later on, even if there is paucity of the time, later on we can discuss with the expert. So by this, I would like to request Dr. Tanmoy Kumar Kole for initiation of his lecture. Thank you.
Is it visible?
Yes, yes. You can go for the full screen mode, Dr. Tanmoy.
I have, okay, full screen now. It is full screen.
Might be, but in my case, it is still not in full screen mode.
Oh, okay. You see, please check it.
No, sir, it is not in like PPT mode. Just do one thing, just
Share.
stop sharing your stop sharing your screen first. Yeah. Now click on share button and then click on
Shall
enter screen.
I enter screen? That is
Yeah.
better.
Enter screen. Then you can go for
Is it now full screen? Now?
Yeah, it's full screen.
Yes,
Yes.
Dr. Kole.
Yeah.
Good afternoon. Good afternoon, everybody. All the dignitaries, session chairman, and participant here. A very good afternoon from ICAR RCR Patna. Today, I am going to deliver on lecture on microgreen and high-tech horticulture. So, first of all, we should know what is microgreen. Microgreen basically it's a small seedling of vegetables, either it is maybe vegetables or maybe cereals or herbs, and which are harvested at seedling stage. Means when you sow the seeds, when its age about 7 to 14 days, and that stage, if you eat this seedling, then you are consuming microgreens. They are rich in nutrition, flavor, color, and unique texture. Now, if we want to know how this concept has developed in science, the concept of microgreen comes as early as 1980 in San Francisco, where many restaurants they use teeny form of seedlings. Many of you observed that small coriander leaves have stronger flavor than big one. So from this, the idea came in the mind of chef, and they started using as a garnishing their food. But popularity increased in 1990s in California. But this term microgreen later developed around 1998 it developed. After that, it gradually promoted by researcher. Mostly, the idea come from USA. Gradually, after publishing some research paper throughout the world, accept this concept and started work. And as a scientist, I have also started some work because I had some queries in mind whether why this mycogenes, mycogen kya hai, what is that? So mycogenes को मैं क्यों खाएंगे? Why I should eat the mycogenes? Means it is nutritionally rich, functional food. What type of nutrition? Generally, some of the research reported that vitamins and minerals are higher. Some claims are there, but not proven. But it is reported that it contains less nitrate. Nitrate is a toxic compound, so it is also beneficial. Furthermore, unlike other vegetables, it generally produce within 7 to 13 days old. So that time we generally not use any pesticide. So it is a totally contaminant-free produce. Besides this, some bioavailability issues are there. They are bioavailable more, rich in secondary metabolites, and give some new color, flavor, texture. So gradually, the concept developed among the common population, and here most of younger participants are there. They are also now interested towards mycobean, not as a researcher, rather they want to be a consumer of this product. And gradually, some new market has developed, a organic market. So first we should see, really is it rich in some micronutrient? Some of the report shows that the vitamin K content of mycogen is very higher. Here you can see, this is the first work, at least 2012, some research says that vitamin K, that is very important vitamins for our liver function, and that is very high amount in mycogen condition compared to mature condition. Similarly, some similar studies, they found that vitamin E content is much higher, at least 40 times higher than their mature one. Nowadays, there is a good tendency among the young students, particularly girl students, they generally use vitamin E as supplements. And these vitamins, that Evion, that gives some their effect on their beauty. That's why vitamin E also called as beauty vitamins. Now, if they use these mycogenes as a source of vitamin E, that can be very useful for them. Similarly, vitamin C also is higher in this. Some of the research shows that some of the material, mineral, particularly microelement, is much higher, just like iron, manganese, zinc, they are higher in mycogen rather than mature one. However, very interesting things they observed that mycogen content less amount of nitrate and ammonia. So you see, most of you know that nitrate is very toxic compound, and that is not good for health. And that's why if you consume leafy vegetables, they are actually very good high source of nitrate, and that is very harmful for our body. So mycogen, if you take the leafy vegetable in the form of mycogen, that is beneficial. So beside this, there is some active compounds like amaranthus group. They are betalain source, some are carotenoid source, some are anthocyanin source, and they have some beneficial effect. Now, nowadays, everybody know that importance of microgreen, some of you may not know, but some people start to understand, and they, instead of purchase, they want to grow the microgreen. And some of you want to plan now for startup. You know, nowadays concept of startup come. So they are now finding whether you can develop some business on microgreen. So first of things, you need a selection of technique. First is crops. Which crops you shall select? That is very important. That seed, all microgreen, you must remember it should be from seeds. If you want to do potato microgreen, it is not possible because the seed material is tuber. So first and foremost important thing is that seed. Second is very quick germination. If you see, if you are a horticulture, many of you know that some seeds take long time to germinate. So that is not suitable for microgreen. And some of the family are suitable like Amaranthus, Chenopodiaceae, Cruciferae, Asteraceae, Apiaceae, and Fabaceae. They are most suitable. Some are not, like Solanaceae. Why? Because Solanaceae contains some of the alkaloid like solanine that is very harmful for your body. And in early stage, the content is very high. So from Solanaceae vegetables, you cannot prepare some microgreen. Similarly, other toxic, where there is a chances of toxic compound, you should avoid. Most of the things we have seen, আমাদের যেটা বেশি লিফি ভেজিটেবল খেতে পারি সেইখান থেকে কিন্তু আমাদের এই মাইক্রোগ্রিন তৈরি হয়। Those leafy vegetables are suitable for microgreen. Now see for amaranthus, beets, chard, quinoa, spinach, they are suitable. Similarly, this is Liliaceae, some are carrot family, chicory, that is Lactuca sativa, that is from your that family is Compositae or Asteraceae, and last one is Cruciferae. So few popular microgreen also there in market like Arugula, that is from your this group, that your Cruciferae group, some basil, coriander, Amaranthus, pea shoot. Here some techniques are required for produce this pea shoot, and daikon. Daikon is here your radish. Now, we as a researcher, I have tried some legume microgreen, and if you see here that this is their seed, this is germinated form. Many of you know you prefer this germinated mungo, bigna mungo. Sometimes people what is that chana bhiga ke jo khate, that is sprouted, we generally use. Vigna radiata also use. So if we can think of their microgreen, so we prepare this microgreen, and that is very useful microgreen was there, and we work on this. So now after this, important is growing media, because media is here important. You should not grow in soil, because if you go for soil cultivation, you face a lot of problem, residue problem may be there. Another problem is that pathogen. Pathogen is the biggest problem there. Some of you raising hands, but please just wait for my presentation. So ideal medium is 5.5 to 6.5. Low electrical conductivity should be there. Optimum water holding, aeration. All these are desirable character. Some of the common media are peat and peat-based media. Coconut coir have lot of disadvantage. You can see here. Synthetic fiber is also used, but they have some disposal issue. Now other media here available, but they have some problem. But we, based on this, we have designed some of the media based on some media mixture, and we got very good result. If you are interested in this type of production technique, after my presentation, you can contact me. And then is that how to grow the microgreen. That is very important. Mostly hydroponics techniques is important. Here in hydroponics, NFT, nutrient film technique is the best. But you can grow in floating technique also. We have some work. And after that, important is the seed treatment. Why seed treatment is essential? Because you know the main problem is here that media. If your media is good, so there is no problem of germination. You know, when you raise any seedling, there is a problem of dumping off. So dumping off is a major problem. So for that reason, seed treatment is important. Another thing, some of the plants require some treatment for enhanced germination. So osmopriming, matrix priming, this is important aspect. And there is a problem of damping off. So during my earlier institute at Indian Institute of Vegetable Research, we have seen that same problem in alfalfa microgreen. When we grow alfalfa microgreen, we found the problem of the severe damping off. Reason is here that our media was not enough sterilized. So we avoided this problem with sterilization as well as we using trichoderma, because trichoderma is a safe biological control method. So then seed sowing. Seed sowing is very important for smaller seeds. You need some space for larger seeds. But one thing, too much seed is not good. Too less seed is not good. Optimum seed should be there, but it is because of your personal experience. You cannot decide, you cannot learn these things. I cannot teach you, because when you grow these things, you automatically learn how much should be the density. Growing condition, generally high light condition, natural sunlight is better. Not too much humidity is good. Air circulation must be there. For light level, actually what happens when you want to prepare good seedling, you just imagine you are developing some seedling. So high level of light is very important. It makes stronger microgreen. But when the light condition is very poor, low light condition, that seedling become lanky, lamba ho jayega, and that gives a poor result. And if you see that those stout seedlings sustain very longer time, but who are weak, they will very easily. So nowadays there is some concept of artificial light, particularly LED light. One of my colleagues in Haryana, she is now doing that. We have some paper on with her. So she is doing some LED light effect, and very beautiful results are coming, because if you manipulate the light, you can change the color of the product, you can change the content of the product. And most important aspect of microgreen is irrigation, because if you not irrigate it, wilting is obvious, because unlike soil, the media is here different. And in different media, you need gradual watering. So plants should not wilt. Generally, water twice daily is better. Now, harvesting is important, very short growing period, only 7 to 14 days. So harvesting after that, it depends on climate. If you grow the microgreen in winter, it will take long time. In summer, it will take short time. And hygienic practice is important. What type of cutting you are using, harvester kaise hai, and that thing should be sanitized. Otherwise, what happens? These plants are very susceptible to foodborne pathogen. Here, pack house operation is important. Generally, hydrocooling practice, because after your dispatching, you have to wash it and dry it. Dry means airtight. There should not be any water droplet on surface. And after that packaging, there is modified atmospheric packaging is important. But nowadays, grow pack is going on. That inside the package, they have medium, and during transit you will grow. So there is no concept of wilting. So another important aspect of microgreen is food safety. If you see it here, this country, USA, Canada, they have some problem of that food safety issue. So nowadays it is a growing problem in that country. And when we search some researchers that from where these microbes are coming, media, seed, irrigation, water, they are coming. And post-harvest factor, the sanitation condition of the worker and the situation all affect this pathogen. So potential contamination points are there. Irrigation water, seed decontamination is essential. Post-harvest hygiene, and if you follow these things back up, then the chance of contamination will be reduced. And here, a very interesting paper I found that some seeds are very irregular shapes. So there is a chances of pathogen inside irregular, but sunflower is smooth, so there is a less chance of pathogen. So now come to the end of my presentation, that is use. How you can use. You can use in sandwich and your Chinese dishes, Italian dishes. There is a scope because generally foreign country they consume fresh, but Indian stomach may not digest many times. So generally they prefer semi-cooked, and best Indian use can be the stuffed paratha because we generally many people use gobi paratha, muli paratha, methi paratha. So here you can use this ingredient inside the paratha. Now the main topic we came that many young of you are here, you are approaching for planning for some job, and this entrepreneurship opportunity is there in this microgreen, and this entrepreneurship called nutripreneurship. Nutripreneurship means nutritional entrepreneurship, and some of people are doing nutritional entrepreneurship. And here, main important things are how to handle the consumer. In Bihar, I have found some interested people are there, those who are working on diabetics. They actually, where you can sell your product. Diabetes, half of the Indian population are now diabetic. And there is some microbial like your methi microbial, very good for diabetic people. Athletes, they need some electrolytes. So for them, if you can prepare some electrolyte rich microbean, they can take. Health conscious youth, particularly girls, adolescent girls, they need vitamin E because when they are turning from 16, 17, 18, teenage to youth age, that time because of your stress, mental health, you many times causes infection and it create acne to your face. And that time, if you ask your doctor, doctors prescribe vitamin E supplements. If you go for preparation of microgreen from crucifery, they are very rich of vitamin E. And instead of taking Evion, if you take this microgreen, it will improve your health as well as there is no side effect because artificial vitamin E have a lot of side effect. Now, some other aspects are also there because of paucity of time. I cannot move very long, but some of the area that is high-tech horticulture are there. I am going to very glimpses like vertical farmings are there, but still remember all these things in very metro city where their people have purchase power because this cost of production is higher. Another is machine grafting. Nowadays, vegetable also grafting, and you astonished to know that now the grafted brinjal tomato is gaining popularity. Some of the companies selling this product, they are very good because when you go for grafted seedling, they are less susceptible to pathogen and longer fruiting. So this is the advantage, and some company are coming as a entrepreneurship. You can try sensor or IoT based selection. You know that nowadays that have very good area. People are doing. Some of you do research on this. Another is that your smart irrigation technique. That revolutionize many aspects. That use IoT, data analytics, mobile pump. Many things are there, and as a result, you can control total horticulture production, particularly water management on your mobile. So that area is also coming, and generally that metabolite farming. Metabolite farming means now it is a very sophisticated area where your plant secondary metabolite you can synthesize inside the lab. Some have very like Taxol. Taxol is a very anti-cancerous drug, and you can prepare inside the lab. all these have some new area coming. Some require very less investment, some require very more investment. Microgreen is such a area where you need less investment. With less investment, you can earn huge money, but other cases you require some investment. Main things problem is here that people don't know how to go, how to choose the crops. I am working on these crops since 2014. I have worked a lot on microgreen. I have some experience. If anyone are there, they can check me. This is my one of the YouTube channel where I generally put all this information. Another, this is my WhatsApp. If you need this document, please WhatsApp me. I will send the whole document. Thank you.
Thank you, Dr. Tanmoy, for your nice presentation regarding the basic information. What is the microgreen, how we can grow it, and what might be the even the its marketing strategy. Now, I would like to invite the participants. If you have some query, so we can take 3 to 4 questions. Is there any query about the microgreen? So you have an opportunity to direct contact with Dr. Tanmoy Kumar Kole, who is the senior scientist in regional center that is in Patna.
Research complex.
Research complex, Eastern India Research Complex Center in Patna.
One person had raised his hand. So
Mr. Some needs some person at present. I'm not finding anyone at present. Anyway, so meanwhile, I have one small query, Dr. Tanmoy.
Yes.
So your topic is in microgreen and the income generation, high-tech horticulture for income generation. So nicely you have elaborated regarding the different importance of microgreen, how it is actually helpful for our day-to-day nutrition. But that is the associate part. You have also rightly pointed out that the marketing. So is there any reference, as because you were working on that particular core area of microgreen, so is there any idea how it's getting the price? Is there any survey or any other that has been published of you, as per your knowledge or as per your, you can share?
Actually, you can no, there is very limited information on this marketing issue. Main problem is that people, all these people who are working, most of them are scientists, and they are mostly focusing on the what is the nutrition composition, how this can grow, and all these effects. People mostly concise on their effect. What is the different media, light, and what is the composition, pathogen, safety issue. But very rarely I found that any economics of this. Obviously, the economics is very high. And in my presentation, I told that you cannot sell all this product in domestic, particularly local market. You have to find some elite person or very specific market. There might be some athletes who are ready to pay higher price. Elite class, they are ready to so target oriented base. And I am working here a ABI project for last 6 to 7 years. I have found I have contact with one of startup here Bihar. He is working. They have lot of effort, but now they are concentrating on the giving training to the students. They cannot selling their product, because here also instead it is a capital, but they are unable to sell their produce, because India, that money is very important, because when you go for microgreen, that seed cost is very high. So that's the main things. That's why people are not generally not marketing. If they market also, they do not disclose their what is their earning. But I have found this is the main issue here.
Okay. Thank you for your actually enlightening on the particular marketing part also. So hopefully there is no much more questions. So I would like to request the convener of this particular webinar, Dr. Ajit Ghoshal. You can also interact or you can wrap up also for particular this session. So if there is no such question or any other, hopefully they will be asking later on by chat box as a very interesting topic. So I would like to again convey my warm thanks to Dr. Tanmay Kole. He's the alumni of BCKV as well as IRI also. So with this, I actually handed over the microphone to the convener of that particular webinar, Dr. Abhijit.
I am also thankful because here Dr. Nilesh Bhowmik is my beloved senior. He guided me in lot of way, and I know him from 2003, I think, that 2003 onward. And here, all of you, I should say, if you have interest, please note down my number. Okay, you can directly chat me so I can help you, because some people want you people cannot tell now. So if you want, I am writing is in chat bot. So I am sending my WhatsApp number, so you can directly contact with this number. Thank you so much. Thank you, organizer, to giving me such wonderful experience and the opportunity. Thank you. Thank you all.
Thank you, Dr. Nilesh Bhowmik. Nilesh Da has nicely organized, nicely coordinate this particular session. And on behalf of our Crop and Weed Science Society, I sincerely thanks to Dr. Bhowmik and as well as Dr. Kole for giving their nice insights before our participants. So now the session is open for our last session, and that is particularly on digital soil analysis and carbon farming to mitigate the climate risk. Under this theme, the respective session coordinator will be Dr. Sanjoy Shil, who is working as the assistant professor and TIC in Bakura campus of Bidhan Chandra Krishi Vishwavidyalaya, and he is in Department of Plant Physiology. So I am requesting Dr. Seal to please coordinate this session in this particular session. So now it is all over to Dr. Seal to coordinate this session. Thank you. Dr. Seal, are you here? Rohit, please unmute Dr. Seal.
Not here, sir. Or might be joined from different name. I searched his name, but and also the speaker of the session, he is not also here.
Yeah, Dr. De sir has already joined, as he has informed me. He has already joined to.
Which team, sir?
So Dr. Pradeep De sir has joined under the name ICAR Atari Kolkata. So you please unmute the ICAR Atari Kolkata. Okay. So
Sahil, sir.
Now it is unmuted. Okay, thank you.
just a minute.
And now it is unmuted and video is also.
Yeah, sir. Okay.
Thank you.
So our session coordinator will introduce.
Right. Please give very brief introduction. We are running late, so I will try to make up some time also. Okay. Thank you.
Dr. Sagwal, are you there?
Sir, are you there? Please raise your hand so I can identify you from among the participants. If you are joined from different name, no issue, but please raise your hand.
কি নামে? Dr. Sanjoy Sil. Rohit, please unmute Dr. Sanjoy Sil. Dr. Sanjay Shil. It is not showing probably.
Sir, not able to find his name. I just do one thing. I'm
So
just
no,
giving
no,
permission to all the participants. Sir, just one minute. Sir. And just sir, please unmute yourself. I give permission to all the participants. So they can mute.
Yeah.
Just say something.
Dr. Abhijit, I'm here. Hello, hello.
One second. Yeah. Sanjay sir, please speak. Please say something. Sanjay sir, please say something so I can identify.
you are in different name probably.
Okay. So, am I audible?
Yeah.
So it is username. It is you are joined under the name user.
User, a co-host.
Yeah.
Okay.
No, you are
I need to do.
user. Okay. So it is all
Please,
over
please
to
continue.
you.
Okay. So, thank you, Dr. Abhijit Gosal. Today, I welcome Dr. Pradeep De, one of the distinguished scientists in soil science and working as Director Atari Kolkata. So I introduce him just he has very enlarged biodata. So I just briefly point out his introduce him. He specialized in natural resource management, soil science and precision agriculture, and he has over 32 years of experience in agricultural research, planning, strategic implementation and extension. Currently, he is working as a director at Atari that he leads more than 59 KVKs as director with a strong focus on scaling innovations, capacity building and last mile deliveration. And he served as project coordinator AICRP STCR at Indian Institute of Soil Science Bhopal, served as principal scientist at CSSRI Central Soil Salinity Research Institute Karnal, and senior scientist at ICAR RCER Regional Station Ranchi, and scientist at Indian Institute of Soil Science, Indian Institute of Lucknow, and demonstrating leadership and research roles across premier ICR institutes. He holds an MBA in HRM, blending scientific expertise with governance and institutional leadership. And he published more than 500 publications, including 207 research papers. And he developed Mrida Parikshak, a portable soil testing kit contributing to 15% of soil health cards. And he is a pioneer of STCR-based nutrient management, conservation agriculture strategies, and bioamelioration of degraded soil. So, and he also executed 64 research projects that mobilized more than 32 crore through consultancy and external funding, and including for 64 research projects that included 22 in-house projects, 21 national importance, including 2 consultancy projects, 21 externally funded projects. And regarding his global engagement and recognition, he represented in India, in Australia, USA, Kenya, Germany, and Bangladesh, and served as biome expert lead in Netherlands, SARC focal expert, and contributed IIASTD 2009 global reports, and soil scientist in expert knowledge exchange program in Kenya. So regarding his award, he was awarded World Bank Social Innovator Award, to gold medal, 6 fellowships, and more than 40 recognitions. And he was elected as fellow of West Bengal Academy of Science and Technology, Kolkata, during 2018, the Indian Society of Soil Science to New Delhi, 2022, and Indian Society of Agrophysics, New Delhi, 2024, and Indian Society of Soil Salinity and Water Quality, 2014, and Indian Academy of Horticultural Science, 2018, and the Indian Association of Soil and Water Conservation, Dehradun.
I think since
he-
we are running late, let us
Okay. So
Let me
you
allow
have,
to
sir,
start
you
the-
have diverse biodata. So I welcome you, and I would like to request Dr. De to present his presentation on
Thank you.
digital soil analysis and carbon farming to mitigate climate risks. So
Thank you, Dr. Shil. Thank you so much
Most
for
welcome.
so
And enrich us.
elaborated introduction. So first of all, I would like to thank our this society, Crop and Wheat Science Society of and all the office bearers of this society and our session coordinator, Dr. Seal, and all others for giving this opportunity. So let me quickly go to slides for further presentation. Okay. So clean the screen and share. Just I'd like to, it will come shortly. Is it visible from that side?
Yes, sir. Yes.
And please tell me whether it is moving also. It is moving, I think. Slide.
Yeah, it's moving.
Oh, thank you. Thank you. So this is this presentation. Through this presentation, I'll deal with somewhat digital soil analysis, plant health monitoring, and carbon credit optimization through this presentation. So just giving the brief setting on what and how we are actually operating as on today. So in that, is it visible everything or there is some guard in between?
No, sir. It's
Visible.
no.
So this is the thing that we are operating. We have to have about 1/3 of what we are producing now, more than 1/3 in fact, by 2050. So 35% more food production. Then that has to be achieved with, now it is about 22% forest area that has to be increased by 33% because this is the commitment of Government of India. So forest area will take some part, and then build up area for residents as well as for industry. So that has to be catered, and then again food production has to be increased, and 35% reduction in carbon emission. So food production needs to increase 35%, carbon emission needs to reduce by 35%. Then again 11% forest area needs to be increased, and we have to cater for all the build-up areas like residence and industry. So in this setting, agriculture needs to be more efficient. And one of the efficiency factor that we always talk about, that through precision agriculture, we can achieve that. And in precision agriculture, if we think of One Health, that is now Government of India as well as Indian Council of Agricultural Research, through all institutes, KVKs, we are propagating the idea of One Health. So One Health, the first pillar is soil health, because what plant produce is what it gets from soil in terms of nutrition, and then from plant, ultimately animal, birds, even in the silt part, we get in the fish, and then to the human, and we don't have to stop even at the human level. We have to go to environment, and we have to secure the environmental pollution level, and green environment we have to create. So all these things, in one way or other, if we do precision agriculture, then we save chemicals, we save input, and we can produce more. That's why digital and precision is buzzword of today, and we have to do that. Then climate change is another factor which is aggravating the situation, and be it drought, cyclone, or heavy rain, or heat wave, or flood. This climate change is actually posing another type of stress in the production system of agriculture. Another thing we can see over here, that at FAO level, it was enumerated that last 70 years, vitamin and particularly micronutrient, hidden hunger of micronutrient, 2 billion people, and vitamin level in the food has reduced to a great extent. And all these are somewhere related to soil function. Soil function related to productivity is one function only, but we have like filtration, regulation, carbon sequestration, biodiversity management, and nutrient provision and cycling. These are also important. You know, 1 teaspoon of soil almost contain more than 1 healthy teaspoon of soil contains more number of microorganisms than the human population living on the earth today. And that is actually responsible for soil, all soil function and all soil activities. So soil function will be optimum when we can maintain the soil biodiversity and we can check the soil pollution also. And this is the productivity, waste recycling, and environment protection, how these are related to different soil function, and then what are the principal soil properties, those are related to soil function. That is given in this slide. Not to burden too much of all the audience, except for those who are dealing with natural resource management, but this tells in nutshell that there are some key management strategies and soil properties associated with the soil function, which in turn associated with our management goal of more producing more with less input and waste recycling and environmental pollution. And these are the, out of 17, these are the ticked 1, 2, 3, 6, then we have 11, 12, and 13 and 15. These are the SDGs that are directly related to soil quality. And then peace and justice and strong institution, the 16, and partnership, 17. Partnership
Yeah,
of
sorry
any
to,
kind.
sir, sorry to
Ah.
interrupt. Your slide is being now paused.
Is it? It is not moving.
No, it is in the screen is not showing probably.
It is not moving, isn't it?
No, sir. It's on the side creating sustainable agriculture future for 2050.
Just 1 minute, 1 minute. I will again share. Just see, is it moving now?
Yes, sir.
Okay.
Yes.
So we were actually here that soil function, and then how functions are related to management goal and soil properties, and how SDGs that I was talking, that different SDGs are related to soil quality and ultimately productivity. And this slide shows that how soil quality and ecosystem services, those are related. And in many cases, actually, it is called planetary boundaries. That means how much tolerance power of our this earth or carrying capacity of the earth, that is more than that is actually produced. And that is called planetary boundaries in terms of biodiversity, in terms of biomass production, in terms of say erosion and other thing. So in many cases, actually, these planetary boundaries are actually crossing every time. So that is another factor which is very, very important. And this, is it moving now? Hello?
Yes, sir. Yes, sir.
Is
Yes,
it?
sir.
Okay.
Yes,
So
sir. It is
soil
moving.
quality and different, okay, soil quality, soil function, and different indicators. So without burdening too much all the audience, one thing just I would like to project here, there is one indicator that is called soil organic carbon, which we call master indicator, because this soil organic carbon is appearing in many cases when we segregate different key indicators which are related to different soil function and ultimately to soil quality. Like here, biodiversity and productivity function, filtering, then nutrient cycling, and also other factors. Those are indirectly, and these factors are directly related to soil organic carbon. That's why soil organic carbon is called the master indicator. And in one of our study in STCR, what I was dealing earlier, we have seen that principal component analysis when we do, then again, and we arrived at soil quality index, then also both for PC, principal component 1, 2, 3, 4, when we do with principal component analysis and then superimposing with the expert opinion and then coming out with the main or key indicators, then again soil organic carbon is coming as one of the major indicator, both for quality as well as for fiber quality as well as productivity. When agriculture began for many long time, actually, we could manage the productivity level at a higher level, but then it declined. And it declined to a great extent. But whether it will stabilize here, where question mark is there, or it will decline even further if we don't take any management, offset management practices. But if we take some offset management practices, then perhaps will be able to increase. So it is not that we will be always maintaining at this level where we are operating. If we don't take a specific offset management practices, we can go down even below than this, and then our productivity will be hampered to a great extent. And all these cycle, water, nitrogen, and phosphorus, potash, whatever cycle you can see, those are in fact governed by carbon cycle. That's why carbon is called the Lord of Rings. And this is if one brick is considered, single brick is considered as a kind of representation of how much carbon is there. Just to visualize, this atmosphere is having one brick, and all land biota, whatever trees and all, that is another brick. If you add these two, soil itself contains carbon of more than, in fact, slightly more than this. So just to visualize. And then coal, oil, and gas, these are 10 and these 3. So one line is 10. So 13 bricks is here, actually trapped. And ocean, it means 1, 2, 3, 4, 5. So 50, 51, 52, 53, 54, 55, 56, and 57 bricks. And below that, in the ocean, 27,000 times of bricks, means 27,000 bricks. One brick is certain amount of carbon. So that means here, if we chant something, it will be disastrous for human, even ocean, even here. But soil is not very simple. If you disturb to a great extent soil also, then whatever we are trapped in atmosphere and land biota, together these two we are having total in the soil itself. So that means disturbing soil too much will be emitting lot of carbon, and that may be difficult to manage. And these are fluxes of carbon from different sources. Actually, if you see this 1.6 is outside, 5.5 is outside, and 2 is actually inside in the ocean. So that means outward flux is more. And whatever we have cutting down of trees and all, whatever coming out from these and soil respiration, through sequestration also we can manage to some extent. But still we are having outward 1.6 gigaton of carbon. Here flux is from oil, reserve, gas and coal, 5.5 outward. So this is 7.1 and 2 is inside. So net there is about 5.1 is net outside flux. And that is the problem for the world. So this is net increase in flux is 5.1 gigaton of carbon per year. That is actually 1.5 ppm per year if you take it volume wise in terms of total atmospheric volume. Okay, what we have in the earth. Sorry, it is going other side. Another thing is microplastic. That is also creating problem because microplastic in between soil, when it enters, then two particles of soil, they go apart, and because it is not having any binding capacity like organic carbon, it is actually soil is opened up, and again it is giving some kind of carbon emission, adding to the carbon emission apart from its own toxic behavior. Okay. So that is creating mainly these two part, that is aggregate stability is actually hampered, and water stable aggregate. These two parts are hampered by microplastic pollution in the soil. So it acts as barrier, prevent formation of stable aggregate, and that's why it is a problem. Then what are the strategies towards digital or decision support system of apps? What we are doing at the National Agriculture and Research, Education and Extension System, NARS system. So through institutes, universities, and KVKs. So some DSS has been prepared. One of the DSS, it was during my earlier stint with as a national coordinator. In the soil health card scheme, this particular in the soil health card scheme, STCR was actually made inbuilt, and that was inaugurated by our Honorable Prime Minister that time. We had also in the Northeastern zone, we have Kiran portal where STCR was included. And then we have one standing alone CD-based system of decision support system at Tamil Nadu, but developed through our TNU Center of STCR, and that was adopted by the Tamil Nadu government also. And this one online system was developed by our STCR center at Karnataka, US Bangalore Center, and this was also adopted by Karnataka government. And one app we could develop at that time, that is in Marathi and English, bilingual, and Hindi. So this app was actually for Maharashtra through our MPKB STCR center. Kisan 2.0 is another particular point where anybody can reach, and they will get more than 300 apps at a particular place. And Social Shamala, one app is also there where you can get agriculturally important apps, verified apps, and download and use those apps. This is one app developed by our Ganjam KVK just recently, and more than 1,000 download already crossed. And this is the first time one crab farming app was developed, and it is being downloaded not only in Odisha, West Bengal, and many places in India. This digital agriculture through Kishan Sarthi, this was actually, now we are in 2.0 Kishan Sarthi. Now more than 2.75 crores of farmers registered, more than 6 crores advisory already sent, and more than 3.43 lakhs of villages covered. And this we are revamping now in 2.0 version of this, and through app it is also coming. Now strategy, another strategy is using artificial neural network, and first time we could from our CFLD oil seed last year, we could get this insight by using ANN, that how different parameters, so a lot of parameters were studied when, but there was some masking effect. So through artificial neural network, we could segregate which are the most important parameters that is affecting in our zone, the groundnut yield and productivity. So through this type of thing also, that like artificial neural network, you can segregate data and pinpoint which are the most important or critical indicator that is affecting inland quality of a particular crop. Strategy 3 will be utilizing drone in digital agriculture, and in our zone and throughout ICR also, we are using this for precision input application. We could use less input and we could get more actually output. Then large scale outreach of adoption also it was done, and sustainable service delivery. So we can also use the drone with hyperspectral camera. Now it is possible to run the drone and develop different layers of, say, what is on field. And then if you superimpose with the soil fertility map, then you can generate at different places how you can variable rate of application of fertilizer is possible and nutrient is possible. Strategy 4 is use of spectral signature for soil analysis, particularly rapid soil analysis. During earlier stint at ISS Bhopal, we did this study, and it is possible to use near infrared and mid infrared. These two things particularly, and we have seen that MIR, that is mid infrared, is specifically very good. Of course, FIR is also there, but mainly we could see that MIR is very good and very rapid. Of course, NIR is also, it is possible. And it is most important thing is very little sample is required. Very little means in terms of grams. Within 10 to 15 gram of soil, you can analyze and generate data. Here actually we create this type of spectral signature of soil, and a library is developed, and through that library, by matching of unknown spectra, we can get what is the content of nutrient in a particular soil or PHEC. We have seen that organic carbon, PHEC, and particularly this clay content and silt content, this can be very well judged by this process. And this actually just 2 days back, we could get this certificate also. We copyright, where first spectral signature library was in fact developed, and after coming over here, that was actually now it is being dealt by our Kajili, and then in that we could get the first this copyright of first Indian spectral signature library that was actually done. Strategy 5 will be digital and autonomous IPs also. Our KVK is not only doing the, say, FLDs and then some demonstration and training, they are also engaged in some type of IPs, and I am happy to share that solar powered autonomous weeder 2024, we could get this design certificate. We have won copyright of IFS model selection 2024 end. That is what may be the particular agroforestry model that can be selected through the software. And then non-invasive plant stage detector, this design was also obtained from one of our KVKs. So 2 from KVK product and 1 from Atari directly. So this is actually this type of things we are also doing, and through this it is possible to detect stress, to have autonomous application of some activities, and segregating what is the best suited model for a particular agroecology. Then strategy 6 is towards net zero, and this is one very good thing happened in our zone, and Nodia KVK got the first net zero certificate from Carbon UK, one of the most reputed audit agency of the world. But more than that, we could develop one agriculture carbon footprint applicator, this assessor version 1 and 2. And these particular assessor, through these it is possible to assess, and this is actually make in India, you can say, and first assessor we could develop, and this particular software will give the idea how actually carbon in a particular system is operating. And then through this carbon emission strategy, either through carbon trading or green development mechanism or joint implementation, 3 types of mechanisms are there: market-based carbon management strategy and trickling of this profit towards the farmer, that is possible. And then through this actually carbon green development strategy, we can actually harness benefit for our farmer in a cluster mode. And you know that this is a kind of win-win situation where a particular industry which is actually you can say forced to emit some of the pollution because of their own economic activity can in fact purchase the carbon credit from other place, and both can save. Here you can see, if this particular company itself want to generate, then it needs to spend about, say, it will have to generate about, it has to spend about 40,000 rupees. But it can spend only 20,000 rupees and save 20,000. And other company, what is actually carbon trading company, like one KVK can be a trading company, like our Nadia KVK already net zero, in fact less than net zero. So they can sell out that, and that can be purchased. In turn, the benefit to the carbon selling agency and to the agency who is purchasing without generating carbon credit on their own, both can benefit from that. And you know that carbon trading, now emission trading is more than carbon taxes, and it is gradually towards emission trading we are moving. Basically, to 2016, carbon tax was more and emission trading was only 1/4, that is 25%, and 75% was carbon tax. 2020 already it is 50-50, and now 2021, this one is 1/3 and this is 2/3. We are moving more towards carbon trading system, and we have to energize all our system toward this. This is some World Bank data, how we are moving in carbon trading. Sorry. And this is our carbon registry. Government of India has already put in place, and through different, say, whatever Government of India has different times, they have issued different orders. Through that, I have just chalked out this one, how national law passed by Parliament to establish carbon market, and then not to burden with everything, Government of India has committed that by 2070 it will achieve net zero. But our experience from Nadia KVK, we can say for sure that it can be achieved much before that. And all the KVKs and all our institute, all SAUs, and in a clustering mode, different farmers, they can harness benefit from this carbon registry type of thing. This is India's journey. 2021 in COP26, Honorable Prime Minister announced the net zero target by 2070. Then 2022, India submitted the long-term goal in COP27. 2050 projected 20% decrease in rain-fed yield if the business as usual. And it will be a disastrous effect. That's why we have to go for net zero, because it will ultimately decrease the yield of rain-fed rice, which is very important. And 2070, we are aiming that. But through this IORF, this collaboration with Atari, we could achieve net zero in Nadia KVK. And these are some of the activities that was done in between and how we could achieve net zero. Not going much towards this. This is the, let us see, this was covered by ICR also and in different media. And this is the emission side and carbon mitigation side. And this is the certificate that was issued by I Know Carbon UK. And you can see that minus 73.992, 74.992 tons actually, 74,992.1 kg. That means 74.992 tons of carbon equivalent, that is negative, means it is less than net zero. Net zero is just equal. So it is 1 kVK. Just by enumerating and doing some good management practices and green management practices can achieve this. So we have 731 kVK throughout India. We have so many SAUs, so many 113 ICR institutes. So we can achieve this thing, and clustering of different farmers organization, FPFPCs, we can achieve before 2070 this net zero. And we can actually sell out our carbon credit. And this is what I have shown here, that how farming community and corporate sector, they can join hand and both can win from this carbon trading market. So policy metrics, maybe first one is land governance, extension and advisory services. These are also required. Then local governance and cooperation of say FPFPCs, NGOs, KVKs, SAUs, ICR Institute, and government, state government and central government. All corporations are required. Then finance and market, maybe banking finance also, and refinancing bank like NABARD, that is also required. And then monitoring and evaluation at all stages. Then we can achieve this net zero target. And we have now available dual purpose solution of arresting land degradation and managing our input more efficiently, where through GIS and GPS based system, we can track our, and we observe and take action for betterment of farming community and soil as a whole. And this is the just a schematic diagram how we can proceed. So I think this will show you that each parcel of land that has to be enumerated and special variation has to be governed, and through mobile telephone and cloud network system, we can directly deliver the through Internet of Things to the farmer's mobile. And this is a schematic diagram how Viksit Bharat 2047, what are the problems, action and outcome. And through this type of digital and online system and precision system, we can achieve net zero as well as better and precise management of soil health, plant health, as well as our environmental health. And we can achieve the ecosystem services. You know, there are 4 arms of ecosystem services: providing food feed fiber, that is provisioning approach, then controlling through carbon sequestration, support service through nutrient cycling, and by managing or reduction of fertilizer and then managing soil to a great extent, we can also touch the our cultural arm of the ecosystem services. So we can manage our all the natural resources for betterment of farming community as well as better agriculture and better national wealth. Thank you very much for patiently listening and giving this opportunity. Once again, I'd like to thank all the organizers for giving this particular opportunity to share some of my thoughts with you all. Thank you very much.
Okay, sir. Thank you, sir. Thank you for your valuable and enriched talk. So now the session is open for question answer interaction. If anyone, if any have any question, please.
If anybody is having any question, we can discuss it for some time.
Hello, sir.
Yes, please.
This is Ramvilas Moldik, Department of Agronomy, University of Calcutta. Sir, can you listen me?
Yes, yes, absolutely.
Okay. this is the first time I listen your lecture. You made it as clear as water. So I don't have any question. I listen your
Thank you
lecture
so much.
very carefully because without healthy soil, we cannot produce any healthy crop. That you made it clear. So thank you, sir.
Okay,
I have
okay. Thank
become
you.
your fan. Okay, sir.
Thank you.
Thank you, sir. And if anybody have any question, please. I think no question.
So once again, I would like to thank Crop and Wheat Science Society, all the organizers for giving me this opportunity and all the delegates for patiently listening. Thank you very much.
Okay, sir. Thank you, sir. Thank you for your nice presentation. Now I request Dr. Ghoshal to continue this program, and I hand over this to the Dr. Ghoshal, please.
Thank you, Dr. Seal, for nicely coordinating the session. I am also thankful to Dr. Pradeep Desai, Director ICAR Atari Kolkata, for accepting our invitation on behalf of our esteemed society, that is Crop and Wheat Science Society.
Actually, I had no option. Dr. Ghoshal was pressing so hard, and he is also with us, one of our colleagues. So no other option I had.
Yeah.
Sir, it is our privilege to hear you, sir. On behalf of our society, we once again, thank you for your nice presentations and give your insights to our participants and delegates. And approximately more than 270 participants are here from different parts of our country. It is from different SAUs, ICR institutes, NGOs, and varied group of participants are present here. With this, I want to conclude, or we have already concluded the four technical session of this particular webinar, representing the title, that is the Contemporary Agricultural Technologies for Sustainability and Risk Mitigation. So now it is the time to go for the wrap up the overall lectures, whatever the eminent speakers have delivered during this particular webinar. So now I request Dr. Shamoli Das, Assistant Professor in Department of Agronomy under Bidhan Chandra Krishi Vishwavidyalaya, to please coordinate the next valedictory session. Dr. Das, are you here? Can you hear me?
Yes, I'm.
Yeah, so it is all over to you. So you please coordinate the next valedictory session. So thank you.
Thank you, Dr. Ghoshal, to provide me this nice opportunity. Now we are heading towards the closing part of today's webinar. That was mainly concentrated on four distinct different thematic areas of most pertinent and important agrotechnologies that is relevant to our recent agricultural scenario, as were delivered and discussed by your respected resource persons of repute. Now it's the high time to sum up the outcome of all the lectures delivered today to provide a good message for the academicians, agri professionals, and research workers for ultimate use of farmers. I request Dr. Biplab Mitro, respected professor of the Department of Agronomy, Uttar Banga Krishi Vishwavidyalaya, an eminent scientist, learned academician, and a true farmer's friend come guide, to give the valedictory talk of this webinar. Dr. Mitro, please.
Thank you. Thank you, Dr. Shamoli. I think I'm audible to everyone.
Yes.
Yes, sir. Yes, sir.
Good afternoon, everyone. This is Dr. Biplab from Department of Agronomy, UBKV. And I will try to summarize the deliberations of today's webinar in a concise way, and also to highlight the take-home messages for the participants, mostly our young researchers. The theme of the webinar is Contemporary Agricultural Technologies for Sustainability and Risk Mitigation. To our understanding, it is actually based on integration of advanced digital, biological, and mechanical technologies to fundamentally transform agriculture 4. So in this regard, we had 4 deliberations today from 4 eminent scientists. First one was on agronomic advancements and policy reforms in rice research, a case study from Indian Punjab, which was delivered by Dr. B.S. Dhillon, rice agronomist, Punjab Agriculture University. That presentation synthesized agronomic innovations, varietal advancements, and enabling policy reforms that have collectively reshaped rice cultivation in Punjab, with a special emphasis on water-saving technologies and direct seeded rice. And that is mostly through a prolonged integrated approach with reoriented breeding strategies, fine-tuned agronomic practices, large-scale mechanizations, competitive paddy straw utilizations, and mostly strong policy backup. Overall, the case study demonstrated synergistic integration of science-led agronomy, targeted breeding, mechanization, and policy reforms, which can transform rice system from resource intensive to resource efficient. Recent advancement in plant protection conserving biodiversity was the next lecture, which was delivered by Dr. Pranjit Chakraborty, former member of ASRB and former ADG Plant Protection and Biosafety ICAR. He highlighted the economic significance of crop losses due to pests. In India, it is a huge loss. I was even astonished to see the figure. It is close to around 1.9 to 2.25 lakh crores. Dr. Chakraborty detailed out the invasive pests, diseases, and weeds causing huge damage to our crops, and also huge role of transgenics or even GM crops to mitigate the problem. There remain certain challenges. Mostly the academic knowledge hardly prepares our students to tackle the problem, and even farmers are not at all aware about the novel technologies. Even extension workers are also unable to transfer these technologies. And above all, certain policy issues, especially non-compliance and flaws in laws. So ultimately, he emphasized on advanced research, use of effective chemicals, strategic IPM modules, and strengthening public-private partnership, and also enabling policies to protect these losses. In the post-lunch session, Dr. T.K. Kole, Senior Scientist, ICAR Research Complex for Eastern Region Partner, delivered a fantastic lecture on microgreens and high-tech horticulture. We know that microgreens are nutrient-dense, edible young seedlings of various vegetables and herbs, and their production is at the forefront of high-tech horticulture. Microgreens as a superfood has certain key benefits. It is rich in nutrients, it provides several health benefits, they offer a burst of flavor, color, texture, but obviously he highlighted marketing is a problem though. Again, high-tech horticulture, including vertical farming, hydroponics, aeroponics, that provides the ideal environment for cultivating these delicate crops year-round. The synergy between microgreens and high-tech horticulture addresses the modern challenges of food security and nutrition by providing a sustainable, locally grown source of fresh, nutrient-dense produce. The final lecture was on digital soil analysis and carbon farming, which was delivered by Dr. Pradeep De, Director ICAR Atari Kolkata. Dr. De emphasized on achieving a sustainable agri-future by 2025 through clear transition from generalized soil management to precision-driven, data-backed decision-making, with soil health serving as a both productivity driver and a climatic solutions. And as sir highlighted, it was really a nice presentation, sir. Being an agronomist, I also enjoyed your presentation. Soil organic carbon lies at the core of this presentation, and restoring soil organic carbon, therefore, is the fundamental to sustainable intensification and climatic mitigations. The impact of soil sensing is amplified through digital agriculture information system, integrating decision support system, mobile apps, and agriculture IoT-based solutions for continuous soil crop monitoring and precision nutrient management. And sir, as you have highlighted, if we move in that way, we may be one of the strategic contributor to net zero emissions. So it is clear from these 4 deliberations today that contemporary agricultural technologies are revolutionary farming, and by integrating data-driven insights and automation, we can enhance the sustainability and mitigate risks from climate change, resource depletion, and labor shortages. And I would request our young researcher, mostly our students and the young faculties, scientists, to focus on certain key technologies for shifting our agriculture to a new dimension. And I would say that these technologies, or the contemporary technologies, that may include your precision agriculture using GPS guided machinery, drones, sensor, biotechnology and genomics, which involves genetic engineering and gene editing techniques, automation and robotics that employs autonomous machines or tools to perform labor intensive tasks with high precision, Internet of Things and AI. It collects vast amount of real-time data on soil moisture, crop health, weather patterns, and then analyze this big data to provide farmers with actionable insights, which is very important for the technologies and particularly the researchers who are actually operating at ground level. And emphasis has also to be given on smart water management, and controlled environment agriculture is also an important area that includes practices like vertical farming, hydroponics, aeroponics, where crops are grown in a controlled indoor environment using minimal land and water. And finally, I would say these technologies may mitigate some agricultural risks, more importantly, the climatic risks, because ultimately we have to come out with certain technologies for adaptations to extreme weather events like droughts, floods, and as an agronomist, our duty also is to stabilize yields under these odds. Environmental risks, in which precision technologies and organic practices like conservation agriculture, integrated pest management, that can minimize the soil degradation, water pollution, greenhouse gas emissions, so that in a long run, it can ensure sustainability. There are also certain operational and economic risks, and use of contemporary technologies can also address these issues like optimizing input costs, labor shortages, improving production efficiency, and enhancing the profitability and resilience to market fluctuations. And ultimately, this is our strong belief that building consumers' trust and allowing farmers to respond quickly to quality issues that are equally important along with the technological backup. So we can conclude that this transformation towards present-day farming is mostly driven by achieving long-term environmental and economic sustainability. However, the technology would be building resilience to mitigate systemic risks such as climate change impacts, resource scarcity, and labor volatility. Hope we will move ahead with these key points. Thank you. Thank you all.
Thank you. Samalidi, are you here?
Or Abhijit, you can conclude, no problem.
Okay. Thank you, Dr. Biplab Mitra, sir, Professor of Department of Agronomy under Uttar Banga Krishi Vishwavidyalaya, for a very lucid way. He has concluded the total 4 lectures under the 4 themes delivered by the eminent speakers of repute. So thank you very much, Dr. Mitra, for this nice and lucid discussion in a nutshell of this total webinar So thank you on behalf of our Crop and Wheat Science Society, as you are also a part of this organization. So there is nothing to be a thank. So it is just a protocol of this decorum of this webinar. So thank you very much. Now I request. I am also thankful to Dr. Samoli Das also for nicely coordinating this valedictory session. So now we are at the end. Now I request Dr. Sujit Odhikari, the organizing president of this webinar, to deliver the vote of thanks of this webinar. So Dr. Odhikari, you are please requested to deliver the vote of thanks. So now the platform is over to you. Thank you. Dr. Odhikari, are you there? Dr. Odhikari, are you there? Please unmute yourself. Dr. Odhikari, please unmute yourself. Dr. Odhikari, can you hear me? Please unmute yourself.
So yes, sir, please unmute yourself. You are visual, please unmute.
Hello,
Yes, sir, audible, sir. Please continue.
am I audible?
Yes, sir, please continue.
Okay. Thank you, Abhijit. It's my privilege to confer the vote of thanks for this highly impacted national webinar on contemporary agricultural technologies for sustainability and risk mitigation, organized by our beloved Crop and Wheat Science Society. It is wonderful to note that we received a massive response about this webinar nationwide from different state agricultural universities, ICR institutes, KVKs, allied sectors, government and non-government institutions. It is also important to note that this webinar is attended by the agri-professional as well as students, research scholars with immense interest. I take this opportunity to thank our chief patron of this webinar, Dr. P.K. Chakraborty sir, Honorable former Assistant Director General, Plant Protection and Biosafety, ICR, and former member, ASRB. Also extend our sincere thanks to Dr. Pradeep De, Director, ICR, Atari, Kolkata. Dr. B.S. Dhillon, Senior Rice Agronomist, Punjab Agricultural University, and Dr. Tanmoy Kumar Kole, Senior Scientist, ICR, RCAR, and for their valuable talk during this webinar. On behalf of our Crop and Wheat Science Society, it is our privilege to hear you all, sir. Our society expresses heartfelt thanks to all the delegates present here. Also extend sincere thanks to Dr. Ankur Sharma and his total team of AgriMate Foundation for their all cooperation to use their Zoom platform and their wholehearted effort to smoothly conduct this webinar a grand success. Our society expresses thanks to Dr. Abhijit Ghoshal for coordinating the whole nice webinar along with all our session coordinators, Dr. Pradeep Sagwal, Dr. Somen Bera, Dr. Nilesh Bhaumik, Dr. Sanjay Shil, and Dr. Shamuli Das for coordinating the webinar in efficient way. I would like to thank Dr. Biplab Mitra, Professor UBKB, to summarize the webinar in a nutshell. I extend my sincere thanks to our Secretary, CWSS, Dr. Sanjay Shah, and all the three conveners, Dr. Abhijit Ghoshal, Dr. Pradeep Sagwal, and Dr. Kiranmoy Barui, for nicely coordinating this webinar. I also extend our thanks to Dr. R.K. Ghosh, former President and Founder Secretary of CWSS, all office bearers, and all the executive members of Crop and Wheat Science Society for their support to materialize the webinar. I am very much hopeful that our young faculties of CWSS Executive Committee will organize this type of nice webinar very shortly. Thank you once again to all. Hello, Dr. Ghoshal.
Thank you, sir. Thank you, sir. So now we are going to conclude that today's webinar.
Vote of thanks should
On behalf of our organizing committee, so I would like to thank everyone who have joined this particular webinar and make this program a grand success. So thank you, everyone, and we'll send your participation certificates in due time to your mail. Thank you, and we'll meet you soon under the umbrella of Crop and Wheat Science Society in future. Thank you very much.
one vote of thanks should go to AgriMeet Foundation.
Yeah.
One vote of thanks should go to AgriMeet Foundation.
Dr. Odhikari has already
Mentioned. It is already mentioned. It is already mentioned.
Thanks to AgriGift Foundation as in detail. So it is all about
Dr.
them.
Ankush Sharma and his total
Helped
team
a
of
lot
AgriGift
to coordinate
Foundation.
this total webinar. Without their help, we couldn't able to make this webinar in such an efficient way. I would like to thank everyone. Rohit is here. He has coordinated the overall program in nice and efficient way. So thank you on behalf of our Crop and Wheat Science Society. So thank you, everyone of the technical team, everyone of this, those who are in, we are using your Zoom platforms and all these things. You have nicely in decorated way, you have planned this program. Thank you very much.
Thank you so much, sir. And it is like privilege to work with you all.
Thank you.
Thank you. Thank you all.